Hi, team. Thanks for showing up for your learning. This is the week 6 Delta Math walkthrough. We are really focused on getting those fraction skills rocking at a high level. And we just want to do a variety of different problems, adding, subtracting, multiplying, and dividing fractions. We're also going to review our exponent laws and do some mental math. You could do the mental math at the beginning, at the end. Just make sure you record your progress on your sheet. I'm going to go top to bottom here to help you with your searching. If you have a question about a particular type of topic, you can search, just see which questions I'm answering and zero in that way. Let's go. Multiplying and dividing fractions. First step, notice I have some blank paper here to do my scratch work because I'm not always going to be able to do these in my head. When we have, let's see, we go on to draw. There we go. Fractions dividing other fractions. I just copy out the question. Divided by 5/7. Then we can flip and multiply. That's the trick to dividing fractions, is turn them into multiplication questions, flip and multiply. I can see here I have no factors that can cancel because 2 and 7 are on the top and 5 and 5 are on the bottom. 5 doesn't share factors with 2 or 7, so the final answer is 2 times 7, which is 14 on the top, over 5 times 5, which is 25 on the bottom, 14/25. Put it in there. Boop, boop, over 25. Boop, boop. And then, hurrah! Yeah, okay, next question. All right. So 7/5 times 1/2. Again, no cancels possible. 7/5 times 1/2. When we multiply fractions, we do top times top, so 7 times 1 over 5 times 2. You can see the answer is 7/10. Yeah, and then next problem. All right, 3/5 times 6/5. Well, if you can just do that in your head now and say that's 18/25, you're on the team. And if you can't do it in your head yet, no problem. You just keep practicing, okay? And how do you keep practicing? Do level 2. Here we go, level 2. 1/9 times -5/6. Okay, so here we got negatives showing up again. I have one negative multiplying one positive. The answer will be negative because you just count the negative signs. If it's odd, then the answer is negative. If it's even, the answer is positive. That applies to multiplication and division. Okay, so here, not addition and subtraction. Let's go. 1 times -5 is -5, divided by 9 times 6, which is 54. 5 and 54 don't share factors, so this is fully reduced. Yeah, next one. Here we go. 5/4 times -10/3. Well, the answer is negative again. 5 times 10 is -50. 4 times 3 is 12. Oh, my answer is not correct. Of course it's not. Here, I'm rushing a little bit. My goodness. Here's how I ideally see this problem in my head. 5/4 times -10/3. And you all know that I put these mistakes in there deliberately, right? No, I make mistakes when I'm talking. What I should notice is I can get out my cancellation pen if I want to be really fancy here, is that 4 and 10 share a factor 2. So I'm going to divide both of those by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. And that's how I break those down in my head. You could also do this like this. 5/2 times 2 multiplied by -5 times 2 over 3. I just wrote this problem in a new way, and then I can see I got a 2 living upstairs and a 2 living downstairs, and they cancel. And that gives me the answer here, -25/6. 25 and 6 do not share factors. They're what we call coprime. So this will be the correct answer. Yay! One more. All right, 1/10 times 2, that's 1/5. 1/5, because the 2 cancels the 2 and the 10. And it helps to write these out as 1/10 times 2/1. 2 is 2/1, it's not 2/2. So when I cancel this 2 and that 10, it leaves a 5. So that's done. Final answer. Oh, it's going to make me wait for it. Did I lose internet? What's going on? Oh, no. Let's just refresh. Sometimes it needs a quick refresh. Here we go, a new problem. Hooray! We get to, and I got the points for that one, so great. This one, just for fun, would be -5/14. Cool, yay! All right, go back. Let's get the next one. Multiplying and dividing fractions and mixed numbers. Okay, so here, if I look at an example, I bet they're going to convert these to improper fractions. I sure would. Okay, convert each number into an improper fraction. Yeah, good idea. If you're ever doing this, improper fractions are easier to work with. So let's go. Let's go next problem. All right, here we go. 1 2/3 divided by a quarter. Okay, so I want to convert 1 2/3 into a mixed number. So you can visualize these. This is 1 2/3, okay, because this is one whole made up of 3/3, and then that's 2/3. So altogether, that's 5/3. You can visualize them for small ones, but if I asked you to do 8 4/5, it's really cumbersome to do that. So what you want to do is see that this is here. Let's look at a slightly more complex example. 2 3/4. Okay, so here's 1, here's 2, divided into quarters. That's why I'm dividing it, and 3/4. So I see a multiplication method I could use here. This is 2 times 4. That gets these ones. And then plus 3. You do the number of wholes multiplied by the denominator, and then add the numerator. Okay, so it's this times this plus that is how you kind of go around the problem here. So 8 4/5 is going to be 8 times 5 plus 4, all divided by 5. The numerator stays the same. And so that's 44/5. Anyway, 1 2/3, we know that's 5/3. So let's go. We're going to take 5/3 and divide it by 1/4. That's like saying how many quarters are in 5/3? Well, there's going to be a lot of quarters in 5/3 because we flip and multiply. This is 5/3 times 4/1. Notice I just flip this one and multiply. So that's 20/3. And if you can start doing these, 20/3, expressing it as a mixed number now. So now I want to express that as a mixed number. Now I say, how many times can I fit 3 into 20? Well, 6 times 3 is 18. So this is the same thing as saying 6 times 3 plus 2, that's 20. 6 times 3 plus 2, all over 3. So I have 6 wholes and then 2 left over. So this is 6 2/3. All right, that's how we convert back to a mixed number. So this is 6 2/3. Hooray! Let's do another. All right, 3 7/9 times -3/10. Okay, so negative. So this is negative times a negative. I know my answer is going to be positive, so I'm going to ignore the signs and just put in a positive answer. That's my method. No, this is positive. Now let's work it out. So this is 3 times 9 plus 7/9 times 3/10. I'm just rewriting 3 7/9 as 3 times 9 plus 7. 3 times 9 is 27, plus 7 is 34/9, times 3/10. And now you could say it's top times top over bottom times bottom, but wait, there are cancels available. Do your cancels first. Cancel that 3 and that 9 and make that 3. This cancels down to a 1. I divide both of them by 3. And then I see that 34 and 10 both share the factor 2. So let's take out the factor 2. 10 divided by 2 is 5. 34 divided by 2 is 17. Okay, so now we're left with 17 times 1 on the top over 3 times 5 on the bottom, 15. Okay, so there we go. 17/15, that's 1 2/15. Let's just convert that to a mixed number. This is equal to, and if you can see it right away, that's great, but it's also 15 times 1 plus 2/15. Okay, so here's my 1 whole, and here's my 2 left over. So that's why I get this answer 1 2/15. Yay! And let's do one more. All right, 2/9 divided by -6/5. Cool. As a fraction in simplest form. All right, sure. So it doesn't mind if I give this one as an improper fraction. That's great. So 2/9 divided by negative 6 over 5. Here, I just know the answer is negative, okay? So I'm going to think about it like this. Negative, and then I do 2 over 9 times 5 over 6. I flip this one and multiply. I move the negative out there because I don't want to be distracted by it. I just know the answer is negative, so I figure out what the answer is and make sure it's negative. 2 times 5 over 9 times 6. But wait, there's cancels available. That's a 1, that's a 3. And so my answer is negative 5 over 27 because 9 times 3 is 27. Hey, let's keep going. All right, add and subtract fractions. Can't wait. I love adding and subtracting fractions. All right. Okay, so when adding and subtracting fractions, unlike multiplication, you need a common denominator. You need to be able to have both of these fractions over the same thing. So if I have 9 over 5 minus 1 over 30, there's a hard way to do it and an easy way. The hard way is to multiply over here, top and bottom, this is annoying, top and bottom by 30. And over here, top and bottom by 5. I just take this number, multiply top and bottom over there, and this number, multiply top and bottom over there, and then reduce my answer. But this way is harder than the way I'm about to teach you. But the way I'm about to teach you requires that you can notice things about these numbers. 9 over 5 minus 1 over. I'm going to write 30 as a multiplication. 5 times 2 times 3. Those are all the prime numbers that multiply to 30. How did I do that? I do that this way in my head. 30 divides by 2 gives me 15. 15 can't be divided by 2, so I check the next biggest prime number, which is 3. It does divide by 3 and gives me 5. 5 is prime, so those are the prime factors of 30. 5 was already prime over here, so I didn't need to do that to it. Okay, now I can see that the number 9 over 5 is jealous of this denominator. They're like toddlers. This denominator says, hey, he's playing with a factor 2 and a factor 3. I want a factor 2 and a factor 3 as well. Okay, so multiply them in. 2 times 3 over 2 times 3. Notice if I divide 6 by 6 or 2 times 3 by 2 times 3, I didn't change the number. I'm multiplying by 1. Multiplying by 1 doesn't change 9/5, it just writes it in a new way. So that's 6 over 6 times 9 over 5. I would never write it down as 2 times 3. I'd write it down as 6. Okay, minus 1 over 30. Okay, that's this. It's the original question. Okay, so now let's do this multiplication first before we do this subtraction. 6 times 9 is 54 over 6 times 5 is 30. There you go. 9 over 5 is a little bit bigger than 2, is a lot bigger than 1, a little bit less than 2. And hey, look, that's still a lot bigger than 1 and a little bit less than 2, because 2 would be 60 over 30. Minus 1 over 30 gives us 54 minus 1 over 30. They're all over a common denominator, so just subtract them. Subtract the numerators. You got 54 things and you take away 1 things. The things happen to be 30ths. So the thing they are stays the same and you just do the subtraction. So my final answer is 53 over 30. These are lovely problems to be able to do mental math. Once you can do problems like these in mental math, I believe you'll get a similar pleasure to doing math as what I get. Okay, let me do this one in my head. This one, I actually have to add in a factor 5 on the 11 over 3. So that becomes 55 over 15. And on the other side, I have to add in a factor 3. So that becomes 9 over 15. So I have 55 minus 9 over 15. 55 minus 9 is 46. 46 and 9 don't share factors because 46 is not divisible by 3. So there, final answer. 46 over 9. Oh, 15. Yeah, sorry. 46 and 15 don't share factors because 15 is factors 3 and 5, and 46 is divisible by neither 3 or 5. Hooray! So we can do these in our heads. All right, 1/4 minus 7/4. Hooray, we get an easy one here. So here, if I have 1 of something and you take away 7 of that thing, then I must now have -6 of that thing. The thing that it is doesn't change. So this is negative 6 over 4. But it can reduce. Oh my goodness. See what happens when I'm talking? Negative 6 and 4 share factors. They share a factor 2. So I'm going to divide both those numbers by 2. This will be correct. Hooray! Let's do level 2. All right, level 2. Negative 5/7 plus negative 1/42. All right, so this is a very math type problem. All right, both of them are negative, so I know the answer is going to be more negative. All right, it's like a cold day that gets colder. It's going to be more negative. So I just write it out. 5/7, but it happens to be negative, plus a negative thing, well, that's just minus. I would never write plus a minus thing. I'd just write minus 1/42. The cool thing about 42 is it's divisible by 2, gives me 21. It's divisible by 3, gives me 7. It has that factor 7 in there, along with a factor that's 6. 6 times 7 equals 42. This fraction is jealous of that factor 6. So I'm going to multiply that in, 6 over 6. So what we get is 30 over 42, but it's negative, minus 1/42. So this is equal to, remember, it gets colder, negative 31/42. That's like saying it's negative 30 degrees out and it gets 1 degree colder. Well, it's negative 31, right? But you can see how it's easy to make a mistake there. 31's prime. So it doesn't share any factors with 42, so we're done. Notice I wrote 40. No, it's 42. 42, 42, 42. Okay. Hey, come on, Delta Math. Come on. All right, let's refresh. It's loading. Let's see how we do. Get a new question. Sometimes yeah, it did. See, I got the score for it. It just didn't give me a new question. All right, negative 9/10 plus 1/100. Let's convert these to percent, okay? So this is negative 90% plus 1%. Okay, that would be negative 89%. So it's negative 89/100. I know this because I can do it in my head. Don't worry, I'll write out the next one for you and show you step by step, regardless of how easy it is. Okay, let's go. It's fun for me to do them in my head, so let me have my fun, okay? Let me have my fun. You can have fun with these two. You're allowed. All right. Now, this one is a very good example. Thank you, Delta Math, for this example. Negative 1/4 plus 3/10. One thing I haven't been mentioning is you always want to start with a guess, okay? So what are we guessing here? Negative 1/4 plus 3/10. Well, 1/4 is like 0.25. 3/10 is 0.3. So I'm expecting an answer that's positive, but very, very small. Very, very close to 0, but still positive because I have a negative thing and then I'm adding something that's slightly bigger. It's going to be slightly larger than 0. Okay, so start with that guess and then do the work. Here, I might write this as 2. So what am I doing? Oh my goodness. Negative 1 over 2 times 2 plus 3 over 2 times 5. And that's so I can spot the jealousy amongst the denominators. This denominator over here says they get a factor 5. I want a factor 5. So give it to them. Multiply by 1. You're not changing them. You're just giving them an extra thing. This denominator is like, but that's still not fair. They got 2 factors 2. I've only got 1 factor 2. So give them an extra factor 2. Okay? And then you're going to get this line. 5 times negative 1 is negative 5. 5 times 2 times 2 is 20. All right? And 3 times 2, we're going to be adding 6 over 2 times 5 times 2. Well, that's 20. Okay? So now you got negative 5 plus 6. It's negative 5 degrees out. It gets 6 degrees warmer. Well, that's 1 degree, but it's still over 20. Okay, so 1/20th. Yes, very barely bigger than 0. And actually, for those in the know, that's 5%. 1/20th is 5%. So when I said this is negative 0.25 plus 0.3, some of you probably already said, well, that's positive 0.05. So it's 5%. Same thing. Okay, let's go. Let's get some new problems here. We need some new problems. Proportional reasoning, don't mind if I do. At the neighborhood grocery, half pounds of salmon cost, I got a phone call. Let's go. All right. Half a pound of salmon costs $3.45. Gianna spent $19.32 on salmon. How many pounds of salmon did she buy to the nearest hundredth of a pound? Well, we gonna need a calculator for that. My goodness. Okay, let's get a new color here. We're gonna work in black. This feels like I need to be a little serious with this question here. Here's what I would do. I would find the unit rate. This is one way. Okay, how much does 1 pound of salmon cost? So if 1/2 a pound of salmon costs $3.45, then what I can do is multiply both by 2 to find 2 times 1/2 is 1, and then 345 times 2 gives me $6.90. Okay, so this is the cost of a pound of salmon. Not anymore. A pound of salmon is like $20 nowadays. Maybe you can get it for $14. Anyway, this question old. All right, that's fine. All right, so now we know that she spent this type of money on salmon. Clearly, she bought like almost 3 pounds of salmon, nearly 3 pounds. So we start with a guess and then figure it out exactly. This is how you would do it. 19.32 divided by 6.90 or 6.9, same thing. And that will give you the number of pounds. All right. This is one way to do it. You could figure out the number of half pounds she bought and then multiply that by half to get the number of pounds she bought, but this way's nicer. Okay, so here we go. 19.32 divided by 6.9 equals 2.8 pounds of salmon. She bought 2.8 pounds of. Whoa, no, I put a comma in there by mistake. So minus. There we go. 2.8 pounds of salmon. Hooray! Next problem. Oh, so they highlight the numbers. That's very useful. And then method. Find the constant of proportionality. Okay, that's a fancy way of saying let's find the unit rate. Okay, let's find how much 1 pound of salmon costs. I gave you one method. They're giving you a different method. All right, use the given cost to find the pounds. What's the other method? Now, what I'm doing here is important. You want to look at the different ways and understand the different ways. It's going to build your math sense. All right, set up the proportions and solve. Pounds over cost is pounds over cost. This is a cool way, and I'm going to teach you that later. All right, but you can take a look at it and see, okay, she bought some number of pounds and it cost that much money. Well, half a pound costs this much money, and these two ratios will be the same. So if you multiply here both sides by 19.32, you'll clear this fraction there and move it over there. They cross multiplied, which is absolutely disgusting. I don't think you need to do that. I think you're wasting your time. I'll teach you a better method than that. Okay, oops, let's keep going. Proportional reasoning. I'm going to do the whole assignment. All right, gallons used, miles driven. Okay, the table below shows the number of miles driven by Parker's directly proportional to the number of gallons he used. Okay, how many miles can he travel on 44.2 gallons of gas? All right, so we can use any of these ratios. I'm going to use 45 and 1728. Okay, so what we know is 45 over 1728 is, this is actually, let's not set it up this way. This is the way I would set this up. 1728 divided by 45 will give us the unit rate. Okay, that's what I would find is unit rate here. So that's how many miles he will be able to travel on 1 gallon. Because when I divide this out, it will give me the number of miles per 1 gallon. I know that I'm going to get a decimal here, so I'm just going to do that. 1728 divided by 45 equals 38.4. Well, that's great. 38.4 miles per gallon. All right. So that's the unit rate. That's how many miles you go to get on 1 gallon of gas. So multiply that. Next step would be to take 38.4 and multiply it by 44.2, and that will give you the answer. So we've already got that number on our calculator, so just push multiply 44.2, and then proudly give the number 1697.28. 1697.28. Very proud of my calculator skills. Yay! One more. And they're going to show, like you could also set it up miles, gallons, like this, and figure it out. And that will solve to the same thing. And I'll teach you how to do that later. Okay, next problem. And I'll teach you a better way. Their way is like mathemagic. And I generally don't like mathemagic. Okay, Ashley's earnings on the job. All right, let's find the unit rate and then multiply the unit rate by this. That's my preferred method. Okay, so let's go. What we're going to do is put the dollars. We want to find dollars per hour. How many dollars does she make per hour? The language guides you in terms of how to set up the question. So do 514.8 divided by 18 equals, those numbers came from here. Okay, so I can use those numbers to find the dollars per 1 hour. So let's go. 514.8 divided by 18 equals 28.6. So she makes $28.6 an hour. It's pretty nice. And then how much is she making? 11.25. We've already got that number there, so just multiply by 11.25 equals 321.75. She makes almost $322 in 11.25 hours. Well, that'd be pretty nice. We could buy several Nintendo Switch games for that. All right, now let's take a look at compound fractions, and then we're done with fractions for a little bit. Oh, wait, no, I think there's some more there. Perform the operation and simplify the answer fully. Cool, don't mind if I do. So what I'm going to do is write this out as 1/4 divided by -4/5. I notice there's one negative, so my answer will be negative, okay? And then I have 1/4 times 5/4. Flip this and multiply. It's already negative there, okay? So then what's my answer? 5/16, but it's negative. 5 and 16 share no factors. Don't forget that it's negative or you won't be right. There, that's how you do it. Okay, this one doesn't have any cancels. This one is 9/10. Yes, you can do them in your head. You can do them in your head, do them in your head. Get this done fast. Okay, this one is a Bedmas question. I don't know that I want to do it in my head. I can, but you don't want to see me stare up at the ceiling for that long. 3/2 divided by the result of 3/8 minus 7/12. I know that this is going to be a negative number because 7/12 is bigger than 3/8. Let's find out exactly what it is. So let's do that first. This is going to be equal to, one way to do this is to do your rough work off on the side. So I'm going to do that. I'm going to do my rough work on the side. Don't do rough work in the middle of your solution. Do the rough work on the side. Okay, so 3/8. And I'm interested in 3/8 minus 7/12. I see 12 is 4 times 3. So it's jealous it needs an extra factor 2 because 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. All right, 8 is jealous of the factor 3. It wants the factor 3, so I do that way. So this now is 9 minus 14 over 24. All right, 9 minus 14 is -5 over 24. What did I tell you? It was going to be negative. 5 and 24 don't share any factors. So now I'm going to take that and insert it into the main flow of my solution, which is working this way. 3/2 divided by -5/4. 24, sorry. Okay, I see that I've got one negative in there, so my answer is going to be negative. So this, I'm going to flip and multiply. 3/2 times 24/5. But it's negative, okay? It's negative. So I just separate that from your thinking so your thinking is clearer. I see some cancels. 2 cancels one of the 2's in 24, makes it 12. No further cancellations possible. This is -36/5. That's a beautiful type of problem to be able to do mental math-wise. It's doing this hanging thing again. Let's see if I refresh it. Is it going to come back? Did I lose the internet? What's going on? Oh, yeah, I got the point for it. So it's not as good as the green check mark in terms of my mental health, but at least it's still there. Okay, let's do basic exponent rules. To get a few of these. This is as a single power of the, here you subtract the exponents. Oh, why, Mr. Jennings? I've forgotten again. What do I do with these types of problems? Well, you can expand with multiplication. 4 to the 6 over 4 to the 4. This is saying take 6 copies of 4 and multiply them all. 4 times 4 times 4 times 4 times 4, 6 times. Divide by 4 copies of 6. Sorry, 4 copies of 4. These 4 copies cancel those 4 copies, leave you 2 copies multiplying. But the easier way to do it is 4 to the 6 minus 4. When dividing powers of the same base, subtract the exponents. So that's 4 to the 2. And these skills with that skill, okay, so here 6 to the 5 to the 2. In these cases, when you're raising a power to a power, you multiply the exponents. So in this case, it's to the power 10. And I could show that if I do an example here, 6 to the 5 squared. Well, to square something means to multiply it by itself. 6 to the 5 times 6 to the 5. So this is 5 copies of 6 multiplying, 5 more copies of 6. 5 plus 5 is 10. Or 5, 2 groups of 5 is 10. That's why we multiply these here. All right, let's do one more. Okay, this is 4 to the 1. Which I would never say. I'm 43 to the 1 years old. Anything to the 1 is itself. Okay. All right. So now multiplicative fraction word problems. Arun is making dumplings. If he uses a half cup dough for each dumpling, how much dough does Arun need to make 2 dumplings? To solve, we need to multiply 1/2 by 2 because we know the size of the groups and the number of groups, but we don't know the total cups of dough. Submit the answer. Yay! Let's do another one. Okay, Kieran has 6 cups of dough to make dumplings. If he uses 3/8 of a cup of dough for each dumpling, how many dumplings can Kieran make? To solve, we need to divide 6 by 3/8 because we know the size of the groups and the amount total cups of dough, but we don't know the number of groups we can make. Okay, so we want to find out, okay, if I've got this much dough, I know I need about 3/8 of a cup to make each dumpling. So here it's going to be, what is it? Yeah, 6 times 8 divided by 3. So it's a 16 dumplings that we can make. Yeah. Okay, let's keep going. One more. Yeah. Oh, and then it talks us through like blah, blah, blah. Yeah, cool. All right, next problem. Michaela is making dumplings. So there's a lot of dumpling making here. She uses a 1/4 cup of dough for each dumpling. How much dough does she need to make 14 dumplings? Well, she would need 1/4 14 times, or 14 quarters. That would reduce to 7/2 of a cup, or 3.5 cups. So we need to multiply here because we know the size of the groups and the number of groups. We don't know the total number of amount of dough. Submit the answer. Yeah, so that's how those work. Back. Let's do the next ones. Multiplicative word problems, level 2. We're almost done here. All right. Yaritza purchased 9 1/3 pints of ice cream for a party. If each guest will be served exactly 4/5 pint of ice cream, what's the maximum number of guests that she can serve? One way to guide your thinking with these is to say, should the number be bigger than the number of pints I have or smaller? Right? If I multiplied by 4/5, then numbers get smaller. If I divide by 4/5, numbers get bigger. Okay, I know I can serve more people than the number of pints I have because I need a little less than a pint for every guest. So what I need to do here is answer this question: 9 1/3 divided by 4/5. Dividing is flip and multiply, and I'm also going to turn this into a mixed number. Sorry, an improper fraction. So that's going to be 9 times 3 plus 1 over 3. That's me converting that to a mixed number, multiplied by 5 over 4. That's me flipping and multiplying. Let's carry on. 9 times 3 is 27, plus 1 is 28, over 3 times 5 over 4. Cancel the extra factor 2 there and there. 28 divided by 2 gives you 14. Oh my goodness, I can keep going. 2 shares a factor with 14. That's 7 and 1. So I could have canceled the 4 straight away because 28 is divisible by 4. But if I don't notice, it's no problem. I just keep canceling. So I have 7 times 5 over 3, or 35 thirds of a guest. Basically, she can bring 11 and 2/3 guests. That's the maximum number of guests she can serve. She can bring 11 pretty good friends and one really good friend. And she could say to that really good friend, look, I'm going to serve you a little less ice cream than the other people, about a third less ice cream. But don't worry, we can chat after the party, and we can, I don't know, I'll make it up to you. I'll make it up to you somehow. So this is 11 and 2/3. Oh, I'm not right? How am I not right? Where's my mistake? Let's find my mistake. 9 and 1/3. So this is something that can happen to you. It's a maximum number of guests. Maybe the maximum number of guests is the whole number 11, because you can't have 2/3 of a guest. Yay! Problem wasn't in my math. It was in me rationalizing the idea of 2/3 of a guest. Okay, we're going to have one special guest that takes a little less ice cream. Next problem. I guess she is the one that gets 2/3 of a serving. Okay, she's going to underserve herself. All right, Kayla has 2.5 yards of ribbon to make bows. Each bow is made from a piece of ribbon that's 1/5 of a yard long. What's the maximum number of complete bows that she can make? Okay, so here again, we're dividing. I'm just going to, pardon me for a moment while I clear off my paper and get fresh paper. This is what I do. I only have 8 pages there. And when it's all gone, I need to open it again. There we go. Here we go. And then we turn on the drawing. And then we go back to our question. Thank you for your patience with me, everyone. So here again, we are dividing, because we're going to divide those yards of ribbon into some number of ribbons. And each one is 1/5. When I divide by a fifth, numbers get bigger. So I'm going to get a bigger number of total bows than I have yards of ribbon. So I take 2.5 yards of ribbon and I divide that by 1/5. So that is 2.5 is 5 halves, multiplied by, flip and multiply, 5 over 1. So that's 25 over 2. Okay, so what's 25 over 2? Well, it's 12, because 12 times 2 is 24. It's 12.5. But I can't make a half of a bow, and I want to know then the maximum number of complete bows that I can make. So it's a whole number, and then the answer is 12. Hooray! Next problem. All right, 8 guests at Lincoln's party. If each guest will be served a quarter pint of ice cream, how many pints of ice cream will be needed? Well, here we multiply. So I'm going to multiply 8 guests times a quarter pint each, gives me 2 pints. And so I don't need a mixed number. A whole number is fine. Please give them 2 pints of ice cream. That will do it. I multiply here. Great. All right. Now let's do our mental math. All right. Compound fraction, adding and subtracting integers. All right. I'd show you these not to teach you, just to show you what my level is today on March the 23rd, 2023 at 10:20 in the morning, and to perhaps give you something to aspire to. Or perhaps you can laugh at my mistakes. Let's see what happens. Okay, -7 plus 5 is -2. -6 plus 6 is 0. -5 minus 4 is -9. 8 minus 2 is 6. 9 plus 8 is 17. -9 minus 3 is -12. This is 13. This is 12. This is 6. This is 15. There it is. This is 0. This is 1. This is -18. This is -6. This is -4. This is -15. This is 0. This is -4. This is 3. This is -7. This is -17. This is 11. This is 8. This one is also 8. It's the same question. This is -7. 4. 12. 0. 3. 6. 12. -17. 11, 9. Am I past the number needed? Yeah, I am. Oh, you've done 34. Okay, cool. So my best time is 14.8. That was to get 10 right in a row, I think. It was 14.8 seconds. You can try and beat my score of 1.5 seconds per question. If you can't beat my score, don't worry. I do this for a living. But you can beat your own scores from the past and be mildly competitive with yourself. Mildly. Don't go crazy. Okay? Don't be like, oh, I can't do this. I can't improve. I only improve by a little bit. Use it for positivity. Use it to fuel your progress. And if you don't improve on a given day, just say, I probably need a little better sleep, or maybe I didn't eat right, or maybe I'm bothered by what Billy said about Susie, or whatever. Multiplying and dividing integers. This one, it's very important to remember negative times a negative is a positive. Just count the negatives. If it's even, then the answer will be positive. If it's odd, like one negative times one positive, then the answer will be negative, and so on. So here, this is positive 5 because the negatives cancel away. This is negative 16, so there's one negative. This is positive 45. This is 5, negative 2, negative 8, positive 35, positive 3, negative 15, negative 63, negative, oh, that's 7 is negative. It's 8. Of course it's 8. Oh, and I just clocked in there with my 10 out of 10. So you can beat my high score too. My high score before I made a mistake was 10. And I made that mistake honestly. Like, I honestly got that one wrong. I even stopped and thought about it for a second and still got it wrong. And so by taking a little bit of time right now to be like, remember, man, 6 times 7 is 42. It's one of my favorite math facts. And 48 is like kind of just floats in there as, just add another 6. Okay, so let's go. Next topic. Perfect squares. So this one we have to, I have these memorized, so this will be pretty fast. 4 squared is 16. 11 squared is 121. This is 169. 144, my favorite number. 49. 144. Through 9. 81. 36. 25. And you want to memorize these. So if they're not memorized, figure them out. Work them out. Okay, 13 squared. Okay, 10 times 10 is 100. 10 times 3 is 30. 3 times 10 is also 30, so I'm at 160. 3 times 3 is 9, so that's 169. Okay, that's 100, 49, 64, 81, 190, 69, 169, 9, 49, 81, 49, 196, 169, 121, 196, 100, 16, 16, 49, 36, 196, etc. Okay? Beat my best score, or my high score there, 34 out of 10. And have fun. Let's keep going. All right, folks, now let's rock on some order of operations. I've shown you how to write these out on a whiteboard before, so I'm just going to do them. I do the bracket first, that's positive 7, and then I multiply that by 2, that's 14, then I add a 7, that's 21. This, I do the division first, that's negative 9, times negative 10 is positive 90, and then we take away 1, so that's 89. This one here is negative 3 squared, which is positive 9, because when you square a negative number, it becomes positive, because that's actually telling you there's 2 negatives in this problem. This is, again, negative 3 squared, which is positive 9. This is 100 plus negative 7, that's 93. This is 10 squared, which is 100. This is negative 9 squared, which is 81. 4 squared, which is 16, because, well, it's negative 4. 16 over minus 4 is negative 4. Okay. Square that, it's 16. But then it's negative, so negative. All right, here, just going to keep going. Negative 30. This one is negative 23. This one is negative 81. This one's 74. This one's 74. Yeah. No, it's negative 70. I pushed it and I was like, oh, right, there's a negative in there. So anyway, that was that. Do some order of operations, practice, and try and have fun. As much fun as I have when I make a mistake. I laugh a little bit at myself. Greatest common factor. Okay, I want to know the greatest common factor of those two things, and it's 4. Those two things, and it's 2. Those two things, and it is also 2. Okay, I just do a factor tree of each one and prime factorize it. I see 10 is 2 times 5. 36 does not have a factor 5, so the greatest factor is 2. And this one, the greatest factor is 3. And this one, the greatest factor is 4. And then this one, it's 9. This one is 6. This one is 2, 4. This one's nothing, it's 1. This one is 7. This one is 2. This is 3 at least. Yes, 3. Okay, that one's 2. Got to be 2. This one is got to be 2. This one is 3. Okay, and you just practice spotting these. I'm bored. Done. Okay. So I'm not bored. I want to finish the video before lunch starts, so I want to move on to the next things. Least common multiples. Okay, these are useful for creating your common denominators with fractions. It's like the jealous toddler question. You want to just add the factors to the ones that's missing factors. So here, 15 and 2, 30. 6 and 5, 30. 18 and 2 is just 18. 5 and 18, well, we're going to be 90 there. 7 and 6, 42. 14 and 7, 14. 2 and 6. Because 6 is in the 2 times tables and the 6 times tables, then the answer is 6. 9 and 6, so it's 18. Because here, 6 is 3 times 2, 9 is 3 times 3. So we're going to multiply 6 by 3 or multiply 9 by 2, get to the same place. Boop. Okay, so that's how you think about it. 20. This one is 28. No, but what? Multiples of 14. 28 is not a multiple of 6, of course. Yeah. Oops. So I didn't get there. I better go again. Okay, I have to keep going. No more talking. Just do. Oh, I'm past it now. Oh, I passed it. Oh, did I ever? Oh my goodness, I'm so proud. There's that old 56. Okay, that's good enough. Okay. 20 out of 10. There. Made up for my earlier mistake at right at the finish line. Tripped at the finish line last time. Okay, and last one, we're adding this perfect squares 1 to 30 to give you a bit of a workout on bigger numbers, squaring them. And I'll talk about how I do it in my head. I'll even show you some over here because I don't think I've shown you how I visualize these on my mental whiteboard. So let's go. Okay, 30 squared. Well, that one's easy. It's 900. But this one, a little better. 25 squared. Let's say I didn't have it memorized. Okay, let's do 28 squared. I do 20 plus 8. That's an area, okay? And that's one side length, and the whole thing is a square, so it's also 20 plus 8 on the other side. This little part there, it's actually the biggest part. This is 20 times 20 in this box. That's 400. 20 times 8 is 160. 20 times 8 is also 160. Or you can just do this like times 2 because you know you're going to have it once, twice. And then 8 times 8 is 64. Okay, so I add it together. That's 560, 720, 784. Okay, 14 squared I have memorized. 25 squared I have memorized at 625. 12 squared is 144. 4 squared is 16. 28 squared we just did. Okay, so let's add it together again. 400, 560, 720, 784. There it is. 5 squared is 25. 3 squared is 9. 11 squared is 121. 23 squared. It's going to be 400 plus 60 plus 60. So we're at 520, 529 plus 3 squared. Okay, 25 squared is memorized. 15 squared is memorized. 24 squared, did we just do that? No, that's 400 plus 80 plus 80 plus 16. So that's 400 plus 160 plus 16. So it's 576. This one we just did. It's getting memorized, right? This one's 400. This one's also 400. This one's also 900. This one is 36. This one is 64. This one is, okay. So 200 plus 140 plus 140 plus 49. 140 plus 140 is 280. So 680, 729. There you go. Oh, 729. Oh, yeah, there's 27 squared. Right, 729, because I happen to have 729 memorized as a power of 3, and 27 is also power of 3. That's why that showed up there. Okay. All right, so what was my best time? 31 seconds. Let me give you something that you can try and beat, okay? Let's start again. Let's go. Okay, 24 squared. This one. Okay, and that's it for today. Thought I could guess. Thought I remembered it. Anyway, let's go. So, look, I'm complete. Yay! And it took me less than a period. Yay! And I was talking the whole time. You're probably going to be talking the whole time. Well, you do it too in class. Any questions about any of this stuff, absolutely send me an email or hit me up in class. Otherwise, thank you for showing up for your learning, doing some Delta Math practice, and working on you today as a mathematician. I appreciate you and all of your efforts to improve. Bye for now, everybody.